we want to talk to you more about how to protect your water. And of course, we also have the additional levels of testing I've talked to several of you about already. First, I want to thank, though, the people who are working here and who have contributed to putting this event together. So we have volunteers from our BACOG Water Resources Committee. So anybody who is on the committee, would you please raise your hand? So you can see we have a number of people helping out. We also have Faye Sanat, who I have to call out, who is a member of our committee, but she has been working in the BACOG office while I have a vacancy to really help pull this event together. So Faye, thank you very much. Lake County Health Department is our partner in this event. They are doing all the testing of your water samples, and they provide support to our program throughout the year in terms of information and support and help. So everybody from Lake County Health Department, please raise your hand. All right, so those are our people there. Thank you. Also, our BACOG villages and townships, where you probably bought your water test kit, their staff did all the selling. So they took on an extra job to do the bacteria testing, and that's on all our behalf. So thank you to them. And the Garlands. The Garlands for hosting this. Thank you very much. Nice venue. So I want to talk to you for maybe 5 minutes about what BACOG is doing overall about the region's groundwater. So as a private well owner, you're responsible for doing your own home's water quality. That's the bacteria test. But what about the supply for the greater Barrington region? Who's doing that? Well, what we're doing at BACOG really does address the water quality and the water supply in our whole region. And that goes from the village of Barrington and their municipal supply to big subdivisions like Lake Barrington Shores, to South Barrington and Lake Barrington and all the private wells there. If there's municipal water, your municipality tests water quality for you. If you're on a private well, you test it yourself because no one else does. But we're all taking water in our private wells from the same system, the same source. It's called the shallow aquifer system. And if you want to know more about that, the black brochure that we put together that Faye is holding up, that's the one that tells you about this system, how it works. But everyone, virtually everyone who has a private well, almost everyone, I want to say 99.9% of the private wells in this area are in the shallow aquifer system. That's only the first few hundred feet below the ground level. Most people don't spend the tens of thousands of dollars to drill into the bedrock. So we're all taking water and or polluting water in the same system, from the same system, the shallow aquifer system. Now, one thing that is really relevant here is why are we doing anything to help protect the water supply? One, a major one, is the Illinois State Water Survey, where Walt Kelly is from, which is a premier survey in the United States, has done computer models and projects that the water levels in our shallow aquifer system where all of our wells are, will drop between 10 and 20 feet in our area, here in the BACOG area. 10 to 20 feet means people may have to drop their pumps lower first. Then they may have to drill their wells lower, deeper. And then they may have to find a new location for a well. So that, plus the fact that we don't have much infrastructure, piping, to distribute a different water supply, even if we had a different water supply, which we don't. We don't have Lake Michigan water here. So it is in all of our interest to protect the water that we have. So BACOG is helping to do that. The BACOG board approved a comprehensive monitoring program that's monitoring water levels in the shallow system. It was funded a couple years ago, and it will do an analysis of water levels every 5 years. Are the water levels the same? Are they dropping as the state has projected they will? Are they going up? Okay, probably not, but you never know. But we have equipment, electronic equipment in 3 wells. We take manual measurements through the BACOG office and the USGS, which is our partner in this too. From another 15 wells, we take stream gauge measurements and so on. So this is the new monitoring program. And again, it's measuring, it's looking for trends in the water levels, the water supply in the shallow system. And our governments, and remember BACOG is comprised of member member governments, local governments, villages and townships. So they will use this information to decide, to determine the water levels are falling. What else do we need to do? What do we need to do for conservation? What do we need to do in terms of water use restrictions or questions like that? At BACOG, we're also we're trying to define water quality across the region. Not bacteria nitrates, that's contamination, but natural water quality. Do we have arsenic? Do we have elevated levels of anything, fluoride, chloride, anything in our shallow system water? I've been trying to talk to everyone who comes in, I've missed some people, but our level 2 test, which is the sign-up sheets are at the table right there. I want everybody to notice if you haven't signed up, you can sign up right there. Those tests done by the State Water Survey generate information about the natural water quality here in the area. The more information we have from those tests, the better our mapping will be eventually, which we all will benefit from. So these are just a couple programs that we have. Oh, I want to refer you though to, we have a new video, relatively new. With our water committee, we did a video for the elementary schools in School District 220, and it's a very low-key, low-level, 20-minute video of, it's about water, where our water comes from, glaciers, where the water goes, wastewater systems, how those things connect, water supply, water quality, and sustainability, because ultimately our goal is that our water supply, in terms of how much and its cleanliness, will be sustainable for the very long term. So I hope you'll support the regional work that we do when your village or your township is paying its dues to BACOG. It's what we're doing on behalf of the region that one village or township can't necessarily do by itself. So now I'm done. This is my soapbox, just for 5 minutes. And I'd like to introduce our speaker. We're very fortunate to have Walt Kelly from the Illinois State Water Survey in Champaign, Illinois, which is part of the University of Illinois. He is a groundwater geochemist. He's been at the State Water Survey for 14 years, and for the past 3 years, he's been head of the groundwater science section at the survey. He's the author of numerous professional publications about water quality, and he knows something about the water quality in our area, including lead. So please help me welcome Walt Kelly to talk on lead in drinking water. Thanks.
Thank you, Janet. I've actually been at the Water Survey 24 years.
Oh.
Sometimes it feels like 14, sometimes like 30. Thank you all for coming. So I'll just dive right into this. So a few acknowledgments before I get started. This presentation, the bulk of it was actually prepared by Steve Wilson at the Water Survey. He developed this as part of a webinar through the privatewellclass.org. How many people are familiar with that, privatewellclass.org? Okay, I'll have a little more information about that later.
Hold it really close.
Okay, like this?
Yes.
Okay. I'll talk about this toward the end of that to remind you what it is. And then some disclaimers, of course. This is providing general advice. I'm not a doctor. I don't play one on TV, so you remember that reference. So if you have questions about health, talk to your health professionals, including the public health department. And these views are expressed are solely from the private well class and the water survey, and not endorsed by any regulatory agency. So with that in mind, here are the take-home points I'd like you to know. If you space out on the rest of the talk, these are the 4 things I'd like you to take home with you. First of all, most homes have some lead components in their water distribution system, even if you have a new home and a new well. Second, lead poisoning is 100% preventable. There's no reason why anybody should have a problem with this. And to help prevent this from happening, you need to understand your system, and you need to test your water quality. So these are the 4 things I'd like you to remember, if nothing else from this talk. So a few fun facts about lead. The chemical symbol for lead, if you remember your high school chemistry, is Pb. That's from the Latin for plumbum, which literally means liquid silver. It's soft, malleable, ductile, and heavy metal. It's easily extracted from ore and generally easy to work with. And the ancient Romans used lead to make plumbing pipes, and that's where the words plumbing and plumber are derived from. So health. These are some facts from the CDC. Lead affects both adults and children, and at high concentrations can severely damage the brain and the kidneys. Children are more vulnerable than adults. There have been no safe blood lead levels identified for children. In 2012, the CDC lowered the children's blood lead level of concern from 10 to 5 micrograms per deciliter. This is actually good news because all of us have some lead in our bodies because we live in an industrial society. These numbers have actually been dropping for the past 50 or 60 years. Back in the 60s, 60 micrograms per deciliter was kind of the standard they were using because background levels were that high at that time. But despite the elimination of lead in gasoline and paint, there's still abundant lead in the environment. For example, after all that lead that came out of emissions from cars, a lot of soils in urban areas have a lot of lead in them, so don't eat the soil. Okay, so why was lead used in plumbing? Well, as I mentioned before, it's very malleable. It's soft enough to form into shapes that can deliver water efficiently. This is a picture of some lead pipes in Israel, I think. It has a unique ability to resist pinhole leaks, so that's a good thing. And many local building codes mandated that lead service pipes be used for constructing service lines. In Chicago, actually in the plumbing code, they required lead service lines until 1986. And I have a couple of things to pass out. For those of you who've never seen a lead pipe, pass this around the room. So here's a lead pipe, and you'll see the inside's got some staining from some iron formations that formed on there. So don't lick it. And then here's a piece of pipe which has a pinhole leak in it. So this is one of the common ways that pipes fail. And so there's a lot of iron on there. So yeah, very dense. So it was considered a really wonderful material for many years. There's an article from 1916 Civil Engineering Journal talking about how great lead was, how easy it was for using to move water around. Its malleability made it a very nice material. It didn't crack so much, you know. It was great for putting under streets where you had like vehicles going over because it wouldn't break. In a place like Chicago, where you have a lot of freezing and thawing, you have a brittle material that's going to crack under that stress, but lead would bend a little bit, so it had a lot of advantages. Unfortunately, it's poisonous. So, how many lead service lines are there in Illinois? This is a graph taken from an article that was written a couple of years ago, and you probably can't see any of the information on here, but it's the x-axis just lists all the states in the country, and the y-axis lists the number of lead service lines. And it's a log scale, so it goes from 1,000 to 1,000,000 up at the top. And I know you can't see this, but there's Illinois. It's number 1. So we're number 1 in lead service lines according to this particular figure. And it's estimated that about 80% of Chicago properties have a lead service line. So these are being replaced, but it's a rather slow process, and obviously there's lots and lots of lead service lines to be replaced. So what are the sources of lead that might get into our well water? So the lead pipes are probably the worst contributor, but they have been banned in 1986. So if you have a home older than that, this could be an issue for you. But since then, you shouldn't have to worry about this. Lead solder, that's also a source of lead used to join copper pipes. Until 1986, it was often 50% lead. And then brass components such as faucets, coolers, and valves. Until 2012, it could be 8% lead. There's new standards now after January 2014. They can contain more than 0.25% lead. And these are especially an issue during the first few months of use. So these things tend to leach a little bit more lead when they're new. So there's more. Lead packers. These are above well screens that may have been used in wells that were drilled over 20 years ago. And basically what this was to set between the screen where the water entered and the casing above it was prevent sand from basically falling down into the area where the water is being pumped out. And oftentimes these were made of lead because they were malleable. Some submersible pumps manufactured before 1995 may have leaded brass components. And then if your system has any galvanized metal, that has some lead in it as well. It has a minimum lead requirement actually. And these can also form some iron scale that can absorb lead onto them. And in rare instances, lead can be a natural contaminant. You're all familiar with Galena, Illinois, I'm sure. And if you don't know, Galena is actually a lead ore that they mined for many years back in the 1800s for the most part. And in those situations, you could get some lead from the environment. But for 99.9% of the lead situations, it's going to be coming from lead pipes and brass fittings and things like that. So we have our sources of lead. Well, how do we get them into the water? Well, let me first give you a little brief primer on water chemistry and solids. That's to help you understand this. So dissolved components in water can lead to the formation of scale. The most common form is carbonate. You might see this in your hot water pitcher. Sulfate, silica, iron can also form scale. They're temperature dependent. If you have hot water, that tends to form scale more than cold water. And if unchecked, the scale can build up and may cause pipes to rupture. That one pipe I was passing around had some scale that had formed on the inside where that pinhole leak was. And these dissolved components in water can also increase the corrosion. So corrosion is the real reason why we have lead in our water for the most part. So corrosive water can leach lead from surfaces. And this is what happened in the Flint, Michigan instance. And the longer the contact, the more the water can leach lead. In addition to the dissolved lead, these particulates can flake off the scale, the films, the joints, the fittings, that kind of iron material that was on that piece of lead pipe I passed around. That could absorb some lead and then it could flake off and get released into the water stream. So the particles moving through the system can pick up this lead. And also physical disturbances. So if some backhoe work is being done in your property or near your property, that can actually cause the pipes to shake a little bit and release some of this material into the water stream. So there's lots of water quality factors that can affect the release of lead and affect the corrosivity of the water. It's actually a very complicated science, and I'm not an expert on this, but the most important things affecting corrosivity of water are pH and alkalinity, chloride, and sulfate. These are the main factors. So if you're testing your water for corrosivity, you definitely want to at least do these four things. But there's also a lot of other things that can affect the corrosivity of water, the hardness, dissolved oxygen, a few other things like that. So the good news for Illinois, most of our groundwater we would not really consider to be corrosive because of the aquifer systems that we have here. We have mainly sandstones and carbonates and some sand and gravel aquifers. They don't tend to have low pHs or low alkalinities, which are some of the main reasons for corrosive water. So places that are in granitic terrains, like in New England or Virginia, places like that, those are typically going to have more corrosive water in the groundwater. So, not to say that there aren't corrosive waters in Illinois, but we have a less of a problem than other parts of the country. So how can I reduce my contact with lead in water? Well, first of all, have your water tested for lead to find out if you even have a problem. And then if you're concerned, you can let the water run. So flushing out the system is probably the best way to get rid of lead in your service lines. As I mentioned earlier, the longer the water is in contact with the lead components or the lead pipe, the more that the lead can leach into the water. So the CDC has a manual that says 2 minutes. I don't know, turn it on, walk away, do something else, come back, and then you can start drinking the water. But it depends on the length of the piping, where the exposure is, etc. You should also use cold water for drinking and cooking. I mentioned earlier that temperature is a factor that affects corrosion and dissolution of lead into water. If you have sediment in your bladder tank or have a holding tank, you should clean these out because the lead can sorb onto that sediment. And then that sediment can sometimes release that lead back into the water, or the sediment itself can sometimes be moved. And then if you do end up finding that you have a lead problem, you might consider a point-of-use water treatment system. And I'll show you some examples of those in a few slides. All right, warning, I'm going to show you some data here. And this is a study that was done a couple of years ago. And this is to show you how the length of time that the water sits in the pipe affects the lead concentration. So this graph, the x-axis is the lead concentrations. Again, it's in a log scale. And then the y-axis indicates the distribution of the samples up from 0 to 100%. So, oops. I don't have a pointer, I guess. But, so you can see where that line there, that vertical line is 15 micrograms per liter, which is the action level that US EPA sets for public supply systems. So those black dots, if you go up there and then go into the y-axis there, you can see 80% of the samples, if I'm looking at that right, about 80% of the samples are above 15 micrograms per liter. And 20% are above, 80% are below. If you let the water flush for 5 minutes, you can see that almost over 99% of the samples have lead concentrations less than that limit. So just letting that water run flushes out a lot of lead that's in the system. So you can see it goes from about 20% to less than 1% being above that action level. Then they did a follow-up study on some of the systems that ended up having detectable lead even after they flushed the system for 45 minutes or longer. And what they found, don't get too confused by this slide, but it's showing that there are other parts of the system where the lead may be coming from. And the key thing is that where that red circle is, that indicates some levels of lead, detectable levels of lead that were collected in the well itself. So the lead was actually coming off of components in the well, in the well bore itself. So it's not just the piping into the house that can be a problem. It can be actually coming from the well components itself. So how do I reduce my risk? So the best thing is to understand your system. Do you have a well log? How old is your home? That tells you a lot about what kind of components might be in your system. And many of these questions you should probably just ask your driller or your plumber, whoever takes care of your well. They'll know all this information. And then be aware, do an inspection every now and then to look for any pitting or pipe failure, or these little pinhole leaks that might be in your pipes. Blue-green staining is actually an indication of copper, but that kind of copper and lead sometimes act similarly. If you have a metallic taste to the water, it's possible that it could be lead, it could be iron as well. But these are things that if you notice kind of a change, you might want to have your water tested again. And then Janet has already said this a couple times, but remember that private wells are not really regulated once they're installed, once they're put in. You as the owner and the user are responsible for making sure the water is safe to drink and the system is maintained. No one's going to come out and tell you to shut off your well. No one's going to come out and say you can't drink the water. No one's going to come out and take a sample for you unless you pay them to come do it. So it's really up to you. So here's a few slides in case you don't know what kind of pipes you have in your home. So what you want to do is locate the water service line as it comes into the house. And I'll show you a photo in a minute to help you determine that. But that's typically down in the basement. And look for that valve. If you ever leave for a long period of time, you may turn off your water in your house. I sometimes do that. It's that valve you're basically looking for. And then you want to identify a test area on the pipe between the point where it comes into the building and that inlet valve. And you want to expose a piece of metal, and you want to take like a screwdriver, a flathead screwdriver, and scrape corrosion off of that pipe and see what it looks like. So here's kind of what it should, kind of a typical system looks like. That the water comes in on the right side there from the bottom, then goes up past through the water meter, the inlet valve there, and then back into the house. And so the test area is that point where it comes into the house, because that's what your premise plumbing is going to be. The plumbing that's outside, the piping that's outside, going out to the street. So a lead pipe, if you scrape it, is going to be shiny and silver, like that. Okay, and a magnet will not stick to it. It's not magnetic. If you have a copper pipe, it'll look like a penny, okay? And again, a magnet will not stick to it. And if you have a galvanized steel pipe, the scraped area kind of doesn't shine, it just remains that kind of dull gray color. And you can stick a magnet on that, it will stick to it. So, lead pipe obviously is of concern, copper not so much. A galvanized steel can have some lead as part of it. So, those are both possibilities that you have lead that could be getting into your water system. So, sampling your well water. So you want to sample your water to determine these corrosive parameters. And we think it's a good idea to collect a sample every 3 to 5 years, just standard. I mentioned that pH, alkalinity, chloride, and sulfate are all important in understanding the corrosion potential. And then you might also want to test your well anytime something has changed. So the well's been open for some reason, your pump has been replaced, or has been worked on. Or if you notice any change in taste, color, or odor, go ahead and get it sampled then. So here's some sampling suggestions. In the health department, people can jump in here and correct me if they have better ideas. So annually, you should do coliform bacteria and nitrate. Those are the two basic tests in most of this country. That's all you have to do to get your well certified when it's first put in. But these indicate a pathway into your well. So coliform bacteria are not necessarily bad for you. Neither is nitrate as long as it's at a low enough concentration. But these can tell you something about whether water is entering into your well. And then when you first put in a well, and then every 3 to 5 years, here's a few other things. You should do a complete analysis. And these are the kind of things that you might want to look for. Some things, depending on the aquifer you're in, you may want to do certain things. So talk to your health department, your local experts on these things. Arsenic is a problem in certain parts of Illinois, including down where I live. So that would be important. It's not so important up here. There's a few places where there is some arsenic, but not like down in central Illinois. And then, like I said, get advice from your local health department and driller for local concerns. So to interpret results, if you don't understand these results when they come back to you, just take them to your health department. They'd be happy to discuss them with you. They're there to help protect your health. A lab can also evaluate your analyses for corrosion potential. So the analysis that's done at the water survey, we can actually talk to you about what the corrosion potential is of that water. So there are ways to remove lead. There are activated carbon filters for the most part. They're on the market. They're typically installed to the kitchen tap or under the sink. And here's a few examples. One's called Take the Lead Out. So here's some more data showing how these things work. So again, it's a similar graph to what you saw before with the lead concentration on the x-axis and the percentile of samples on the y-axis. And the red dots show the samples that are unfiltered before they go through these point-of-use kitchen tap removal systems. And you can see for this particular study that was done by the US EPA, about 30% of the samples were above this 10 standard. And that's brown and green samples on the left side. Those are the samples after they pass to the filter, brown being a new filter and the blue being a used filter. And you can see they do a very good job. For the most part, almost all the samples were less than 1 microgram per liter, which is in many cases kind of below the detection of a lot of our analytical systems. So these things do work very well. But there are some recommendations about it. They have to pass the standard that's set by the NSF ANSI, which is an organization that sets standards for things like this. There's a lot of information on their websites if you want to follow up on this. If you go to a big box store where you can buy these things, you want to read the label on the box, make sure it has that certification seal from NSF and ANSI for the standard. They're pretty easy to install if you're handy. If you're not, ask your local plumber to do it for you. And this is important. You want to test your water before and after to make sure it actually works. Okay. And then finally, most importantly of all, these devices are like any other thing any other kind of treatment you use with your well water. You have to maintain them. If you don't maintain them, they will stop working after a while. So it's the same thing for these point-of-use systems. If you don't follow the instructions about when to replace them or when to regenerate them or whatever, they won't work. They'll stop after all, they'll fill up basically. So, just a few more slides. There's lots of resources on lead available at this privatewellclass.org. So I'd recommend you take a look at that. And I would really encourage you guys to get online and look at this particular website. The private well class has been set up to educate private well owners. It's a series of 10 lessons that you get via email over 10 weeks. It's a self-paced thing. No one's going to stand over you and demand that you do the classes each week, but it's up to you. But they give you a lot of information about your well, about how to maintain your well, how to understand water quality issues, things like that. It's a great resource. It was developed at the Water Survey with funding from the US EPA and the Rural Health Administration. And there's all sorts of resources available on there for different professionals like realtors, environmental health professionals, people like that, and there's videos. So I really encourage you, if you have a private well, please check this out. We also have a public service laboratory at the Water Survey. It provides water quality analysis for well water, $35 for raw water, and an extra $15 for any treated sample that had passed through your treatment. And this is a real bargain if you look at prices from private labs. They can also analyze for lead being an additional charge, and it depends on whether you're sending in additional samples. The price will change. And this is and what the lab does is basically the same as this level 2 test that Janet was talking about earlier. So if you do the level 2 test, you're basically getting what I'm talking about here. The bonus for you is that BACOG is basically taking care of all the mailing, right? I think getting all the material to you. Whereas if you want to do it yourself, you can. You just go to this test website or call us up and we'll send you the bottles. If you want to have the lead done, you need to request that be done, because that's not typically done as part of our normal analysis. If you go to our homepage, there's down there at the bottom, there's something that says water testing. Just click on that. That'll give you the same information. And then my contact information is up there. I have some cards if anybody wants them. I have a few handouts for the Public Service Lab. And I think that's how it's like. I'll leave that up. I'll take any questions if you have any.
The building is built after 1996. You shouldn't have any lead.
You shouldn't have any.
1986.
You shouldn't have any lead service lines. That's correct. But you may have brass fittings that have lead in them.
You should have any lead service,
That's right. You won't have. You shouldn't have any of the piping.
including the well.
Yes. As long as the well is after 1986. Yes. You shouldn't have any lead, but you may have brass fittings that will have, or some solder sometimes will have lead in them as well. So, like I said, most systems, even the new ones, will have a little bit of lead in them because lead is part of brass. So, but it's much less than it used to be.
So when you're saying service lines, the treatment, the ones that come to the house.
Exactly.
And then inside the house, what it's made of?
They can be made of a lot of different materials. Most of the modern ones use PVC, but you see copper pipes, you'll see galvanized as well. So, and lead if it's an old one.
I'm going to interrupt for just a second. We'll take questions for 15 minutes or so. So please feel welcome to stay. I also wanted to let you know we have extra food here tonight. So if you are hungry but you want to stay and ask some questions, we have some sandwiches and cookies on the table here. So please feel free to help yourself.
You've seen the commercial on TV, red water, and then the other new one next to it, red doesn't do the lead, but this one does the lead. Does that really work when you have to make sure you pour your water in there?
For the lead, if it's a certified system by this, yeah, I would say yes, it would, because it has to be tested to do that. I have not seen that commercial.
It's on TV, and it's kind of, I'm thinking poor Brita. They've been on the market for so long, and then this guy's going, oh, no, there you go.
Well, but if you don't have lead in your water, then you would need to buy that extra thing, so. Yeah, that's why you need to test first. Don't go out and buy a device that you're not gonna need. Get all the information you can.
Well, it's just a picture, though. It's just
Yeah.
one that you put in the refrigerator.
Right, and this actually probably has an activated carbon filter in it, so that's what it's doing, probably. Okay.
When you mentioned the blue-green stain,
Mhm.
where do you see that? Is that your passing goes through the filter and sitting in your picture? Or
It could be, yeah, so that's dissolved copper, probably. And so it would pass through your treatment probably. So, yeah, you see kind of coloring into the water. Yeah.
When you talk about PUC pipes, they teach some oxygen or chemical into the water. I know it's a little off, but there's
I don't know. Not that I'm aware of, but, you know, if water sat in a plastic bottle for a long time, it can leach some stuff out of the bottle. So if the water was sitting in the PVC for a long time, maybe, but I don't know. Not really know. I'm sure. That's a whole other field of study, of plastics.
So the copper itself is poisonous, or the?
Copper is not bad in certain, there is a level that it's okay, below which, I can't remember what the standard is. Somebody at the health department knows. Anybody at the health department know what the standard for copper is? Drinking water standard?
I remember. I can't remember, sorry.
Okay.
I think it's
1 milligram or microgram?
ppm.
Okay, so 1 milligram per liter. So that's fairly high for a contaminant. I'm sorry, what was your question again?
Is it the copper itself that's poisonous, or the fittings?
Well, it's what you're ingesting that's the poison. So if you get too much copper, for example, above 1 milligram per liter, it's what you're drinking, that's what's in the water. Once it gets out of the components, out of the piping, the breast fittings. Yeah.
So all of our pretty breast fittings, the faucets, and that.
Well, they all have a little bit of lead as part of their construction. So it's not very much, and we're talking about much less lead than in these old homes. So if you have fairly new fittings, it's really probably not a concern. So, yeah,
Copper's 1.3 parts per billion.
1.3 parts per
The
billion.
EPA standard.
So that, remember, the standards are made for public water supplies. So if you have water above that, no one's going to come tell you not to drink it. So it's up to you. Yeah.
Did you take the question yet, maybe in this part of it, about the residual salt in salted water in relation to public water? I had a question earlier, and I said, in the presentation, you can ask that question.
Oxidation of the iron,
So the question is,
filtered in a backwash.
the question is, if you're drinking softened groundwater, is the amount of residual salt in that water in any way dangerous to people or dangerous because of certain pre-existing health conditions like high blood pressure?
So it's possible that high sodium levels could be in there, and that's, yeah, if you have hypertension, you might want to avoid that. If your water has got salt in it, you'll know it by the taste, and you won't want to drink it because of that reason. But the chloride itself is not really toxic. It just doesn't taste good.
Does the softened water corrode the pipes?
No, not any, my understanding is not any more than the water coming in. Because it's not affecting the components, the constituents that cause the corrosion. They're changing the calcium and magnesium, replacing it with sodium, which those aren't really part of the corrosion process. It's the chloride and the sulfate and the pH. They're more pressure.
Chloride and.
Sulfates and pH. Those are the four most important components of the corrosion. So if we have those analyzed, then the chemist can actually calculate a corrosion index and determine how corrosive the water is.
And Paul, does the state water survey lab test for, I know it's
Yeah, we do all those routinely. Yeah.
So that's part of the level two test, if you'd like to sign up for it, to know about the corrosion capacity or whatever content of your water.
Yeah, so you need to ask for that specifically though. Otherwise, it would just get concentrations of these different metals. So no one's asked about Flint. Yes.
Tell us about it.
Well, so the Flint problem was the corrosivity of the water. What they did was they switched from Lake Huron water, which they're getting from Detroit, to some cost issues. I think they're trying to save some money. And they switched to the Flint River, which was running through Flint. And, which is fine. Communities do that all the time. They switch water, well, not all the time, but they do it on occasion. They'll switch water resources from groundwater to surface water, vice versa, or different surface water sources. The problem was they did not deal with the corrosivity of the water. So almost all public utilities, all public water supplies, put a corrosion inhibitor in their water if it's got high corrosivity. And that's just routinely done. And it's a bit of an art because adding one component, one kind of corrosion inhibitor to one type of water won't work with another type of water, but these guys are trained to know how to do that. Well, to save some money, the people in Flint, either through incompetence or malfeasance, I think some of these guys are going to go to jail, did not add the corrosion inhibitor. And so what happened was these pipes, the corrosion inhibitor, what it does is it produces scale on the inside of the pipe, of the lead pipe, so it protects the lead from the corrosive water. And so what happened was, once they stopped adding that and they had this corrosive water, it started to dissolve that scale that was protecting the water from the lead, and then at some point it reached the lead and started dissolving the lead as well. And so it took a while for them to figure out what was happening because it took a while to dissolve that scale. And once they figured it out, huge levels of lead, as you probably read in the papers, it was a terrible thing. And one of the worst things is it just called into question all sorts of good public water utilities who were doing the right thing, but this one agency was doing something terrible. And people, I'm sure the health department got lots and lots of calls about this because that's something we shouldn't have to worry about. Lead poisoning is 100% preventable if we just do the right things. So that's my understanding of what happened. It was a bad deal.
I don't know if that point was made earlier or not, but lead is not naturally occurring around these areas here generally.
Right.
It's
So
man-made. It's not naturally occurring in the well like other metals, like arsenic, copper is introduced by the plumbing generally. There's corrosion issues. Lead is from the byproduct or the solder or
That's
pipes,
right.
etc. It's man-made materials. So that's why we make that clear. So lead is not something that's naturally coming out of the ground.
not in this part of the world.
Right, not
If
here.
we head to Galena, you'll find some naturally occurring lead. Probably not in the water though. I think it's been a long enough time that it's not there anymore. So, anybody else? All right, thank you very much.
So, again, thank you all for this presentation. He's driving back to Champaign tonight, so I know you will take sandwiches, but also, please feel free to one on the way out. We'll see you next year for bacteria and nitrogen testing. Remember, the test is recommended every year for private well. And again, any interest in the level two, either sign up or on business cards on the back table, if you want to take one and think about it. The blue brochure from BACOG is also about water testing, so you might want to take that home. Thank you very much.
Good. Everyone coming out? Very good.
Good.
law, the law.
And beyond.
I steal the law, the law. You have to sign them, you drop them off.